It's a fairly common practice, whether formally or informally, for graduate students to get together and have what's often called a journal club, discuss a specific paper from the literature, hear other people's perspective on it. Maybe one person leads. Some of you are fortunate enough to even work at companies that have similar projects amongst coworkers or perhaps cross-departmentally. But not all of you. However, maybe what I can offer you is a chance to sit in on one of those journal clubs. Welcome to a preview episode of a new podcast. This is Data Skeptic Journal Club. This is our first spin-off from the plain vanilla main Data Skeptic feed. I hope you enjoy this new experimental format for the show. I'm really excited to be presenting this, and if you like it, please find us on iTunes or your podcaster of choice and subscribe there. Journal Club is an entirely new show which will run in parallel with Data Skeptic. Well, hey everybody, and welcome to another episode of Data Skeptic Journal Club. Quick announcement before we get going. We are going to talk a bit about the COVID-19 virus that we are in the midst of the sheltering operations on in various states from various places. We're aware that this is a common topic on many shows. We are not authorities in this. We are not immunologists. We are, broadly speaking, data scientists who can comment on niche areas of this. For your most relevant news, find out things from the World Health Organization, the CDC, and official immunology type channels. We're going to be talking just a little bit about some of the mathematical models, and I consider our discussions adjacent to that, as will be the topic of the paper I discussed today, which is Beyond R Naught, the importance of contact tracing when predicting epidemics. But before we get to that, we've got a news item and a documentary we're going to talk about from my other two panelists. So I'm joined today by George and Lon. Guys, please introduce yourselves.
Hi, I'm George. I'm a data science student from London, and today I'm going to be talking about AlphaGo the movie.
Hi, I'm Lan. I'm a data scientist in a biotech startup in Oregon. Today I bring a news item about a free and open data set on the COVID-19 literature and research to facilitate global involvement of AI research in this disease.
Excellent. We'll have all that and more after a quick break. You know, they say knowledge is power, and thanks to the Great Courses Plus, we get to tap into that power with just a click. With this streaming service, you can unlock unlimited access to objective, reliable, fascinating information on virtually any subject. Learn from the brightest minds around the world, benefiting from their years of experience and unique insight. With over 40,000 5-star reviews on the Great Courses Plus, you're guaranteed to find compelling content. This week, I delved into it myself and went into the mathematics section. Mathematics is adjacent to the typical data skeptic stuff. We need quite a bit of mathematics to do what we do. We also need some game theory, which I don't talk about nearly enough on the show. So if you want to fill in some gaps, learn about equilibria, start from John Nash and work your way up to auction theory, join me and thousands of other learners by signing up for the Great Courses Plus. Do that at thegreatcoursesplus.com/data. The Great Courses Plus is currently offering Data Skeptic listeners 1 month free. Head over to thegreatcoursesplus.com/data to take advantage of that offer. Nothing to lose. Check out all the offerings. You absolutely will find something of interest. thegreatcoursesplus.com/data. Well, let's kick things off with a segment about the documentary. George, what'd you bring us this week?
Yeah, so maybe this will be a little bit of a cultural relief before we get into the heavy topics. This week I watched the AlphaGo documentary from DeepMind. So this documentary is from 2017, I believe, and it follows the story of the development and then the premiere of the first ever Go engine that beat professional players. The reason I'm thinking of it this week is because I believe this week that DeepMind published it on their YouTube channel. So it's freely available for anyone if you'd like to watch it, if they didn't catch it during its initial theatrical release, which I believe, Kyle, did you see it in cinemas or have you seen it through another channel?
I've seen it. I didn't get to a theatrical release, but I can't recall if it was Netflix or whatever. I had to pay, something $99. I watched it a couple months ago, yeah.
Yeah, it seemed to be pretty limited. Maybe there was one showing in people's cities. There was nowhere near me at the time. But to be honest, I followed the news article, so I sort of knew the story. But there's a difference between the story, what you read on the news, which for me was mostly after the fact, reading what was written about it. I wasn't following along. I wasn't aware of Go. I wasn't aware of AlphaGo, that whole side of things.
Do you think it's worth doing a quick setup as to what AlphaGo is, or do we take for granted if you found your way to Journal Club, you know about AlphaGo?
Yeah, sure. Well, I'll do a little, maybe Go as well. Maybe we need to talk about Go.
Yeah. One of the most interesting factoids I've heard about Go is that apparently, and I don't know how serious this is, but there are people who seriously consider the idea that if there are extraterrestrial civilizations, there's a good chance they also have the game of Go. And you could claim this because it's sort of a very simple and mathematical game. Like, they wouldn't have chess, even if they had a chess-like game, because why would they have come up with exactly the same pieces and moves as us? But Go is, in the same way you could say, well, an alien civilization would have tic-tac-toe, they'd probably also have Go.
It reminds me of Cellular Automata. If there are extraterrestrial life, they must have discovered Conway's life as well.
But so Go, always renowned as one of the hardest games. When I was in grad school, it was somewhat of a hot debate as to whether a computer would ever beat a human being at this game of Go within our lifetimes. And I guess for a large percentage of us, the answer is yes.
There is something to be said about the perspective of this documentary. So it follows the DeepMind team, follows their sort of goals, what they wanted to do. We see the first ever public game of AlphaGo playing Fan Hui, who is a European professional. 2 Dan is what they call him, of a level of 1 through 9 Dan. And I think Dan is equivalent to like a black belt in Go. So it takes a lifetime worth of training. And then once you get to 1 Dan, then you can compete and perhaps get higher. And so the first match between AlphaGo and Fan Hui occurs. And then, of course, some people in the Go community say, oh, well, it's not fair. That doesn't prove, like in the sense that Deep Blue beat Kasparov, who at the time I think was the world's best chess player. Fan Hui wasn't the world's best Go player. So then the goalposts are moved, and then AlphaGo is set to challenge Lee Sedol, who is a 9-dan player, and at the time was the world's best Go player.
And Fan Hui plays a major role in the documentary, correct? That's the guy we're following?
Yeah. Honestly, he is one of the best personalities throughout the whole film. I do have to say that there is an interesting Venn diagram between Go players and computer scientists in that very intelligent and well-spoken, but very quiet and shy. So there's not a lot of talking from the big names.
Hey, it may have the best personality depending on one's perspective.
Yeah, very true. Yeah, so Fan Hui initially is the first Go professional to be beaten by AlphaGo, and then he goes and gets hired by DeepMind and becomes like a Go consultant. They have a professional player within the team who helps them iterate on their design.
And that was one of the neatest parts of it for me, that, yeah, this guy that, I don't know what his aspirations were. Maybe he said, hey, I want to one day be the greatest Go player, but out of the blue emerges this machine, and now he's like, well, I guess I can be a consultant and help you guys improve this thing. Very cool.
Yeah, did the documentary go into the research side of things and how they develop the algorithm and how they train it?
So it toes the line because it's very accessible, the documentary. It does explain sort of the policy network and I think it's the heat map side of things. So the original AlphaGo used 2 neural networks, and it does go into that, but it sort of relies on you knowing what a neural network is. But for the people who don't know what a neural network is, that section is 3 or 4 minutes long. So it really you don't need to know what is going on in order to follow the documentary. So it has this sort of brief bit of expertise, and then it breezes past that. It's actually the same thing. So the other side of complexity is, of course, the game of Go, and the average viewer will not know the rules of Go. I didn't know the rules of Go before I watched the film, and it takes you through the rules of Go as well. And I think it goes into more detail about the complexities of Go than it does the complexities of AlphaGo, the machine.
Yeah, I think so. Although, to be honest with you, I would give it very high marks. I am rather critical of documentaries about science and technology and math because I find a lot of them come up with these hand-wavy answers that make people feel as though they understood things when all they did was remember a little numeric. In particular, I criticize a lot of physics documentaries without naming any names, but it's astounding to me how comfortable people are to come around a water cooler and talk about string theory with me. It's like, oh, I know what you watched last night. But in the case of AlphaGo, I felt like it was smart without just throwing things at you to prove that they had done their research. It left you the right keywords if you wanted to search, but didn't oversell anything, at least to my watching of it.
Isn't it produced by Google?
I got the impression that it's produced by DeepMind. The documentary is very pro DeepMind and pro AlphaGo, but there is respect there still for the Go community. So following on from what you were saying, Kyle, the whole documentary is really accessible. And I think that's because it's not a science documentary. It's not a science documentary in the way that I would say it. It's a sport documentary. It's a film about sports. If you look at the director and the director's past work, his last film was about sled dog racing. And then before that, he worked in the NFL film department. So clearly Google hired someone who would make a sport film, like a proper David versus Goliath story. It isn't heady and esoteric and goes into detail too much, but is accessible to the average person, and certainly has a narrative that is both good PR for DeepMind and good PR for the game of Go.
I'm always curious as to why the AlphaGo be the best player, because I've read some articles online. I don't remember where, so I don't know the validity of it, but it reads to me like something AlphaGo did was kind of unexpected to the human player, and that kind of threw them off. Like, how much of it did the film go into the other human human players is experienced playing AlphaGo, do they have a consensus as to this is really an excellent Go player, or like sometimes it does things that threw me off, so like kind of messed up my game, things like that?
What's quite interesting is, so when they play the match, they have two English commentators who are following the match along, and they're both professional Go players, so they're explaining to the English audience what's going on. And then there's two Korean commentators who are also pro Go players who are explaining while everything's going on. And you'll see Aja Huang, who is I think was the head developer on AlphaGo, who's playing on AlphaGo's behalf, place a stone on the table, and then the camera will change to see the two commentators and their reactions to the move. Either the move is so far beyond what a human would do, or that it looks like it's a bad move, but then when you think it through, it's actually really good, and it's just something that a human wouldn't see. And it's really interesting because, of course, you could have someone sit there and explain like why the move was different, but actually having the professionals react in such a way is very entertaining, because I don't understand it, but yeah.
Yeah, through the lens of machine learning interpretability, this is the most interesting point of the whole project to me, that we came upon this one move that looked like a blunder, right? But as the game unfolded, it turned out to be that move played critically into the strategy that AlphaGo employed, or at least to our eyes appeared to. Really, all AlphaGo did was find a path through a decision tree. We have to ask ourselves, does it have a cognition of that move, or did it just find the right point? It could also be that it got a good move for reasons that aren't easy to explain. As I recall, there was one of the moves that Deep Blue did that was sort of a bug in retrospect, but it threw Kasparov off. As far as I know, people are pointing to this move as like a genuine innovation, different from the Kasparov situation. They're saying like, oh, this is like a smart technique no one noticed before. But now that people are thinking about it, that this innovation was presented to them, they're seeing the value of the strategy. So we can't really anthropomorphize exactly how it is that AlphaGo arrived at this answer, aside from using search, but it did find something novel that all the experts were impressed with, which is really cool.
Yeah, and it's really interesting to see the Lee Sedol, the competition, he speaks about AlphaGo's creativity, or what he perceived to be AlphaGo's personality, and how it plays as a player. And I actually did something there myself. I referred to AlphaGo as a he, which the commentators do, because the commentators aren't used to an engine playing a professional player. They're used to two professional players going off against one another, so they constantly change between referring to AlphaGo as a he or a she, and so there is some level of we anthropomorphize the machine. Because of its accessibility, it is a really good film just to sit down and watch with someone who isn't a computer scientist. I watched it with my girlfriend, who isn't a domain expert at all, and she found it really interesting.
Oh, what's her field?
Classics and English, so very much a way.
That is maybe the best accolade we've gotten today then, so yeah.
Yeah, I'm definitely going to watch the documentary. Sounds very interesting.
Cool. People can find that everywhere. Definitely a good one to watch, as I'm sure there's a lot more streaming going on during the time we're all spending at home here. And honestly, if there's any by chance school teachers listening, assign that to your kids. I think it'd be a great accessible documentary for like junior high and up to watch. But anyway, let's transition into our other news item. Lon, tell us a little bit about the data sets you've been exploring.
So I saw this announcement on Allen Institute for AI's blog. It's a new free data set. They are publishing an effort that includes multiple research institutes, even the White House, because this is a very timely and important issue right now, as we're all affected by this pandemic globally. So the White House AI tool, Allen Institute for AI, and Chan Zuckerberg Initiative, Georgetown University Center for Security and Emerging Technology, together with Microsoft Research and the National Library of Medicine. They put together a pretty impressive data set on publications on the COVID-19 pandemic. This is short for COVID-19 Open Research Dataset, short for CORD-19, right now hosted on AI Tools Semantic Scholar website. We will put link in the show note. But it's also hosted on Kaggle. And Kaggle's doing sort of a sponsor competition around this dataset to kind of spur more interest in the research community to explore it. So this dataset is being continuously updated. I saw on Kaggle that it says the update frequency is about once per week. When it was released, it was like about 20,000 full text, 20,000 scholarly articles. But when I checked it out on March 20th, it was already over 44,000 scholarly articles, including over 29,000 with full text about the COVID-19 disease and the virus SARS-CoV-2 that caused the disease and other related coronaviruses people actively researching on.
So this is on Kaggle. Is that because it's a competition, or is that just where the data is hosted?
The Data Hub is hosted on the AI tool Semantic Scholar. It's the AI power research feed platform that kind of give you feeds of research that you're interested in based on your score of the papers. So they're hosting it on their website. But Kaggle is copying from the source and hosting it on their website as well. So people can easily make notebooks and kernels based on the data set.
Ah, I see. So Kaggle makes it accessible.
Yeah, Kaggle makes it more easily accessible as the input to your notebook, so you can directly import it there. And they provide the free kernels and stuff, CPU and GPU for people to do on their website.
And what sorts of things are they hoping people will do with this?
Mainly, I think it's pretty open-ended. They just want to attract the AI community, the machine learning community to work on it and maybe find novel insights and solutions, because this is an area that is really needing a lot of resource right now to quickly try to use data to inform how policymakers and medicine professionals can combat this disease. So Kaggle, they jump in and listed 10 tasks that were targeting some important questions that are more obvious about the virus and the disease, such as the transmission dynamics, the disease incubation period, the risk factors, diagnostic and surveillance, so on and so forth. This is designed to inspire the community to use this data set to find new insights. They are putting a little bit of incentive. They're putting $1,000 each task for the top entry.
Could we maybe zoom in on one of those? Is there one in particular you find most interesting?
Let me see. I haven't looked in much detail here, but each of the tasks seem like they have already at least a couple submissions or entries already on Kaggle. I find the one about the transmission dynamic and incubation period interesting, just because that's the data or the evidence gained from that kind of study can directly be applied into policy and how hospitals and policymakers decide what to tell the public about this disease and how to advise the public to do the disease control.
Yeah, absolutely.
This is quite interesting because I guess they're asking us to, so there's 44,000 articles. You could just read all 44,000 and then come up with insight, well, with your own brain. But I guess the interesting task here is that it's, of course, impossible to read 44,000 articles, or at least in this short time frame. The idea of, I guess, not necessarily summarizing, but finding some insight in the text. Yeah, it'll be really interesting to see what comes out of this.
Yeah, it would be wonderful if we could put the central limit theorem to good use here. If we could take the transmission rates or whatever statistic that's calculated across all the papers and see the distribution of values, we'd probably be a nice amalgamation. But I think the unfortunate part is that's the non-trivial part. There's no like special markup language for these papers where you could store all those things. And even if there were, it would just be storing a description of the statistical test. It wouldn't be saying, at least there's no way that I'm aware of, to link exactly what the number means or how you computed it. So there is just this hard intrinsic task of saying, how would we merge like with like if we were trying to come up with some aggregate stat like that?
Maybe fine-tune a giant language model and then ask it a question.
Yeah, right.
Yeah, at least with the 22,000 that with full text, you can put the full text in there. Or the 44,000, all of them have abstracts, I think. Most of them have abstracts, so you can put the abstract in there.
Well, full text search out of the gate gives us a huge advantage, I would imagine. Just makes the data accessible to researchers and doctors who are studying one facet of it. And I believe Semantic Scholar gives a lot of options like that. Is that right, Lon?
Yeah, I think so. I think they use NLP models to kind of extract already some things from the article, such as entities and relations and stuff like that. So it is a tool to facilitate easier access of research findings.
So if we were to appeal to civic duty, this is a good opportunity maybe if you're a computer scientist with some know-how in NLP, and I think you'd need a medical student sitting alongside of you maybe to help you figure out what's useful, but to put your skills to work and see if you can deliver some services with this data set that go beyond what Semantic Scholar gives out of the box. All insights are welcome, right?
Yeah, definitely.
Do we have much information about the, I guess what you'd call the data collection process or the provenance of this data? Where's it all coming from?
That's a good question. I don't think I have the full answer here, but looking at the data set, I can see that it has a section that's coming from bioRxiv and medRxiv, which are these open source archives of biomedical research and medical research papers. And there's another section called commercially usable. And most of the papers are in this section. I'm not sure where that's coming from. And there's a non-commercial use section as well. So yeah, I don't really know the provenance of the data set beyond the obvious sections in the partitions in the source.
Yeah, I guess you'd hope that people would opt up their own work free of use to the central data set.
Yeah, I think that during this time, a lot of people are opting for open access when they publish on COVID-19, just to facilitate the use of their finding. Yeah.
Yeah, I think that's critical. Perhaps we should say a few notes here about the printing process for people who don't necessarily know academic publication that well. Perhaps Journal Club has been your entryway into reading some of these papers, but there is a process of peer review. So when you submit a paper to a journal, that journal has, and everyone can be different, but they have some process of how it gets accepted. And what's supposed to happen is that people who are colleagues, physicists double check physicists, the statisticians double check statisticians. And if a pool of your anonymous peers, let's say 2 or 3, all agree that your work is new and noteworthy, so to speak, and correct and all that, then you can be accepted into that journal for publication. Journals develop a reputation. For broadly speaking, journals are good. It's only been in recent years when there's been kind of some fake journals and stuff popping up. For the most part, there isn't a lot of spammy stuff in journals, or at least isn't as much as you see with like spammy websites, but it's out there. And you can look up the impact factor of journals, which is like how often their publications get referenced. So the most prestigious journals are those that influence what people talk about, and there's mathematical ways to study all that. It's been this kind of system that worked pretty well and was the best we knew how to do, but as things have gotten more digitized, that system has come under a great degree of criticism, primarily for some of its paywall practices that are in place, frankly, to pay the bills often. Maybe in an inefficient way, you could say, oh, this organization mismanages. That's not what we're going to get into here, but that is the system that exists, and I'm sure there are good and bad people in it, just like anywhere. Preprint has been something that Data Skeptic is very much in love with. In the main feed in this one, you see us often talking about articles off something called archive, arxiv.org. It is one of many systems, I think it's the biggest one though, where people can just submit their work. So if we write up a publication, we actually skip the peer review process, which is a key thing to take note of, and we print our publication. Now, I think the fact that there's a barrier to entry, it's easier to make a website than to submit a paper to the archive. It also costs you something, I think like $15 or something, but there are little speed bumps in place like that make it a relatively clean system. And for the most part, whether it's an honor system or whatnot, it works pretty good, but we have to acknowledge it skips peer review. But what we gain from doing that is it advances ideas faster. So maybe we've just democratized peer review, and we're not going to necessarily have central journal bodies in the future. They'll just be professional orgs. Who knows how this is going to evolve? But when you have all those steps in place, and they're more important for medical publications, of course, because if I lie and I say I solved the famous P versus NP problem, the only thing that's really going to happen is computer scientists are going to make fun of me because I'm almost surely wrong that I haven't solved it. If I say something like I've proved vaccines are ineffective, that can get published and can be scientifically inaccurate and get retracted later, but yet still have a damaging impact on the public consciousness, which is a thing that happened related to this guy named Andrew Wakefield. So the medical community in response to stuff like that is very sensitive, but now we're in a place where they need to get ideas out fast and people need to kind of skip that process. So like it or not, the medical community is figuring out the preprint system, I guess. Sorry for my long-winded tangent, but yeah.
Yeah. And a lot of these preprint papers, yeah, that you're right, Kyle. The system has a lot of flaws, and slowness being one of them. And a lot of articles on these preprint systems like bioRxiv and medRxiv are eventually going to be submitted to journals and undergo peer review process.
George, I'm curious, out of all of us, you are the youngest academically. What has been your experience as you've gone through school with how one should perceive journals and preprint is conveyed to you?
Of course, my first foray into this, I didn't understand anything about journals. I didn't recognize that archive was something very different to other journals. And I think the vast majority of everything I've ever read has been through archive. It's rare that I seek something out. And I don't think I've ever, apart from textbooks and libraries, I've never sought something out that is behind a paywall. I do have to say that I think until about 6 months ago, I was calling archive arxiv in my head until I went on the Wikipedia and sort of jaw dropped when I realized the X was a chi, not an X.
Yeah, that was totally confusing.
I didn't know it was meant to be a chi. I thought it was like how everyone tries to be clever with their domain names. But anyway, I was on the archive earlier and found a paper that I'm going to cover today. This is Beyond R0, the importance of contract tracing when predicting epidemics. So to kick things off, do you guys know what R0 is? Or do you now, I suppose is the right question?
Yeah, recently started to.
Yeah.
Yeah, I also have been pronouncing it R0. So maybe that's wrong, huh?
Well, it is R0, and if you showed me just the LaTeX equation for it, I would say R sub 0, but R naught is what the immunologists I listen to have said, so I'm going with that. But it is, for those of you who don't know yet, it is the average number of people an infected person will infect. So if it's an R naught of 2, that means if I become infected, I'm likely, on average, to infect 2 other people. So one important observation is that if R naught is less than 1, that's good because it means it'll die out, that I'm going to always infect less than me. Of course, in this case, and in all the cases we're concerned about, R naught is greater than 1. I think there's still debate about it, and even this paper is from February, so I'm not even going to quote what it says, but I've heard anywhere between like 2 and 8 as the R naught factor for the current COVID-19 epidemic. What have you guys heard, by the way?
1.5 and 4.
I've heard as low as 1.5. Yeah, about that as well. Because I think the problem is it's different in different countries, and so different countries have different R naughts for their data.
Yeah, it's gonna be very different.
Yeah, that's a really good
Mhm.
observation. Yeah, it's definitely going to vary by country, or maybe we should say by culture or region, but certainly how many people you come into contact with in the general
Mhm.
path of your life is going to have an impact on it. So it's nice in that it's a single number we can communicate to the public. And just like temperature, they know higher is hotter, lower is colder. R naught we'd like as low as possible. But unfortunately, R naught doesn't tell the whole story, or at least that's the argument made by this paper. And essentially why they say that is because the R naught doesn't well predict or correlate strongly with the number of people who will overall be infected. So let's take a quick look at that core premise. They're saying like R naught is what it is. We're measuring it somehow, but we want to ask the question, what will be the total infected size? Is this going to get to 90% of people or 80% of people or whatever? And that you would expect that as R naught goes up, the infection goes up. It seems kind of logical, but actually counterintuitively, things don't play out that way. My high level takeaway is that this is because graphs are complicated and they do weird things under lots of complexity. But I think another way to look at it is to say that R naught perhaps oversimplifies the situation, that it looks only at like the average, which doesn't tell the whole story. To emphasize that, I'm going to do some quick definitions. I assume everyone knows about the mean and the standard deviation, mu and sigma. Not everybody knows about skewness and kurtosis, so I'm going to do a quick introduction on those. These go in order of moments. If you don't know what a moment is, go learn calculus and come back. It's not that critical for this if you don't, but the first moment's the mean, the second is the standard deviation, the third is the skewness, which, if we're looking at a Gaussian distribution like the old bell curve, skewness tells us how much it leans one way or the other, and kurtosis, the fourth moment, tells us how much it's influenced by the presence of big outliers. So something like income, you could imagine the kurtosis is an interesting statistic because you have the uber wealthy who can massively affect the mean value of the distribution while not being representative of it overall. So when you start getting these other moments, they allow you to see different aspects of it, and even the fact that we call skewness and kurtosis those names, and it doesn't obviously follow from like, oh, that's the third and the fourth moment, but if you sit down and play with the numbers, those definitions do fit. If you also play around with some of the graph theory assumptions about how contagions pass through a network, you'll find through the simulations they ran that just due to the complexities of how things are passed along, that different values of R naught can result in larger and smaller, counterintuitively different final outbreak numbers. So the long and takeaway from this is that while R naught is a nice number, if we're concerned with the final infection size, it doesn't tell the full story.
So, Kyle, can you go over a little bit of the assumptions of the graph theory that they're using, the underlying graph structure?
Yeah, good idea. So they're basing a lot of their work on some OG analysis from this pair, Kermack and McKendrick. Their work is about how epidemics travel through a system. So they establish a couple of premises, some pretty simple stuff I'll go through. One is that the disease results in complete immunity or death. So little binary, obviously in this, as in other epidemics, people get sick and are carriers, but as a simplified assumption, okay. The second assumption that individuals are equally susceptible. Again, not true, but okay, we'll go with it. That's one of those things where, a little hand waving and don't ask too many questions. I wouldn't worry too much about that assumption. Third, the disease is transmitted in a closed population. This one's a freebie in my mind. You can model any system as closed if you draw it big enough, no problem. 4, contacts occur according to the law of mass action. And actually, off the top of my head, I don't remember the exact definition of mass action, but as I recall, it's just the description of the transition function, how likely people are moving around and transmitting this. Lastly, that the population is large enough to justify a deterministic analysis. And that, I love that they put that in. That just means that if we're looking at some small use case, their formulas for the asymptote don't really matter, because if it's a population of 10 people just studying a cruise ship or something like that, you can probably do an exact calculation, whereas we have to to do some sort of simulation or MCMC or something like that, because there's no closed form to these solutions.
In the articles that I've read that have referenced R0 that are for general public consumption, they often describe it as like limited to 100 people, which I believe probably would count as a population that's too small to justify deterministic analysis.
Yeah, I go back and forth on these models. As we said at the beginning, I'm not an immunologist, so it's hard for me to either give credit or give skepticism, because all I can take in is my general knowledge about mathematical modeling applied to specific problems. And what I see in most of the things I'm looking at here is these are very simple models that may or may not beget the bigger complex system. For example, modeling people by how many like network connections you have, that's a big assumption, because you don't really know how many people I talk to, or you don't know the relevance of those contacts. Like, we got food delivery earlier. Do I count that as a link? I have a lot of coworkers that I'm always remote with. Those would be links in a social network that have zero chance of transmission along that link. But when you step back from all of those what ifs, you realize, like, look, out of the whole population, there is some distribution over, you have 1, 2, 3, 4, 5 links, whatever it is. It might even be unknown, but we have to model something. And for sure, that model describes the system. Maybe it's a different distribution that we can't elegantly describe with one parameter or some nice statistical function, meaning we then have to do some really hard computational stuff. But by and large, probably that one's an easy one. The harder thing is about how the network might respond. So, for example, we have had unprecedented global behavioral change in response to this outbreak. That's not a part of the model, right? So I don't know how well these work when describing other systems, or if these are loose modeling techniques. They certainly seem directionally correct. But even from the simple models, we see that they're highly sensitive to their initial configurations, this one really being all about the variance in transmission.
That's very helpful. At least now the listeners will have in their head the idea of a graph where the nodes are people and the edges are connections between people, and that's how disease is spread.
There's another work, I think definitely one of the authors has shared, I don't know whether all of them are, which looks at modelling when there are multiple diseases in the same system, which I think is more accurate to what the current pandemic actually is.
Multiple diseases meaning multiple viruses or different mutation of the same viruses?
Multiple diseases, so like both flu and coronavirus at the same time, or viral pneumonia, and modeling the interactions between them affecting the same people.
Yeah, I was wondering about that because I think I saw an article earlier. I didn't read the whole thing, but it seems to said that coronaviruses has a very low co-infection rate with other viruses. Yeah, I don't know but it seems to suggest that people who came down with it, majority has been infected with that one. The research has to go on very fast with this pandemic, right? It's only been since last December, so I would think most research is not conclusive at this point.
Yeah, Lon, you scooped me on my final conclusion there. It's hard to know. These models are certainly on the right track, but inadequate. There's a lot of unknowns here, and I think those who need to consume this data definitely need to take it case by case and be ready for quick updates. So it's great to see we have data sets like the one you covered, and people can have a central repository for it.
Yeah, what was the other day that you should not take ibuprofen if you have COVID-19 like symptoms? And then there's another article saying that US doctor has evidence to show that ibuprofen is not so harmful. So I'm like, I don't know which one to believe.
Yeah, that's a challenge. I don't know, as a culture, we're going to have to get better at. I don't know the right answer there.
Yeah, no, it's just it's a pretty messy situation right now.
It definitely is, but I hope you guys stay safe, all the listeners as well. Hang in there, and if you've got some extra time at home, we're going to get our reading list up on the site pretty soon so that people can read along with us. We'll make another announcement when that's ready, but that and a number of other things are coming as we're getting things ramped up. But anyway, stay safe and stay inside, everybody.
Yeah, I've been George, and today I spoke about AlphaGo, the movie. Very accessible documentary about DeepMind's work to produce a Go engine. If you've got a spare 90 minutes, it's all on YouTube. The link will be in the show notes.
This is Lan, and I've covered the free dataset available on COVID-19 publications. It's hosted on the Allen Institute